Okay, all right, we are continuing on with part two now. Excuse me. So we're looking at storage and file system management. This is one of the most important roles of, of a network administrator, is making sure that you are handling data in such a way as to obviously not run out of storage space, and make sure that users are adequately user needs are adequately met, and of course, making sure that you're securing access to data, so that users who should not be accessing a particular file or folder do not have access to that. And another important part in corporate file management is, of course, making sure that inappropriate data is not being stored on your servers. So that is an important role of any administrator in taking care of your network, is handling file sharing and making sure that you're keeping a watchful eye on what's happening on your servers, and making sure that there's adequate data space and all the other things that I mentioned. So there's a couple of different ways that you can handle storage in a network, and we're going to look into some of those. But let me get over to here. Okay. So first of all, there is going to be locally attached storage is an option. So locally attached storage, this is going to be some kind of drive or something that is either attached to your server or to your client's device. And so if that's the case, then it could be a hard drive, or it could be a flash drive or external storage of some variety, or whatever the case may be. If this is the case, you're going to have to format this drive for use. Part of that involves creating volumes, otherwise known as an area of your disk that has a partition and is allocated for a file system. When you create a volume in Windows, you assign it a drive letter, right? So we're familiar with this to some degree. In the labs, you guys access a volume known as the data drive, D, right? It's a separate volume. You've got your root drive, or your main directory, which is the C drive, that contains your operating system and everything else. But you also have locally attached storage containing data, right? And in that we have our virtual machines, and you've seen sort of how we do things at Yavapai College to some degree. Is we store our virtual machines locally on your computers in a separate drive, a separate volume. And so in order to prepare a disk for volumes, you must create partitions. And anybody who's in my CNT 110 class is familiar with this. I'm not going to delve into all the different partition types. You can read the definitions yourself here. And part of the problem with these definitions is they are specifically for a particular partitioning type called master boot record, which is sort of on the outs these days. So really the most important type of partition is a primary partition. Primary partition is also considered a volume. It's really not, this next two slides is really not terribly accurate by modern Windows standards, because of the fact that partitioning has been changed so much since the writing of this book. And actually, it's probably GPT was still was even pretty common at the writing of this book, but now it's becoming the mainstream, and how everything, where the direction that everything is going, including Windows Server. So I'm not going to delve into this in too much detail. You may need to know these terms for the purposes of your test, but I'll let you guys look into those. You can look at the definitions. So basically the four partition types are primary, extended, active, active Primary extended active system partition is referring to the one that has the operating system, but what are the 4 types? I'm trying to remember here. Primary extended active. I'm drawing a blank on the 4th type there anyway. But can be found in the book in any event. Those terms are sort of on the outs. What you have now with modern partitioning tables, so this is referring to an old type of partitioning called GPT, and what you have now is known as, called master boot record, MBR, and what you have now is a partitioning table called GPT. And basically every partition is a primary partition. You can have a lot more. You don't need to extend partitions for any reason because your partitions can be large or small, and you can have, anyway. Every partition in GPT is a primary partition. That's really what it comes down to. They don't distinguish between them. So these terms are kind of on the outs. You can really, in master boot record, you can only have one active partition. So that's part of the big drawback of it, and that's why it's sort of being replaced. Basically, that means you can only have one operating system on a master boot record partition drive. So, but anyways, that's all more information than is necessary for this particular class or even this material. You just need to maybe have those terms kind of down. You need to be aware of a system partition. This is the active partition with the Windows bootloader installed on it. And any partition containing a bootable operating system is a boot partition. So this one specifically refers to partition or logical drive holding the Windows operating system files. It's called a boot partition, but really any partition on any disk that has an operating system on it that can be booted would be a boot partition. And then the term dynamic disk, you need to be aware of that. Dynamic disk can be divided into one or more volumes. And so in this case, a dynamic disk would refer to a drive with more than one volume, and that would include partitions, but because of the definitions of partitions and how that kind of the different types of partitions becomes muddy, and you can really only have 4 primary partitions with this in this context. They use the term volume when you're referring to a dynamic disk being something that's divided up into more than one file system, essentially. So you don't see this very often just because there's really no purpose for this other than logical divisions. You might want to allocate half of your drive to a particular to your operating system, right? To be your boot partition or your system partition, and then the other half for storing data for backup purposes or other things like that. But it's pretty rare that you see a dynamic disk where they're allocating multiple volumes on the same drive, unless, big asterisk here, if you're using GPT as your partitioning table, then you might see a dynamic disk that's running 2 different operating systems on it. But that's only in that context, only in that case. So again, a lot of this stuff is beyond the scope of this class. If you want to know more about this, take CNT 110. If you've already taken CNT 110, you've learned a little bit about this already, and kind of how the 2 different partition table types mesh. In fact, we're introducing into the curriculum very soon an operating systems class, which would really delve into file systems in a lot more detail. So if that's something that piques your interest, then CNT 118 might be an interesting class for you to take once we start offering that. And so the way Linux refers to disks is not with a drive letter in the same way that Windows does, but it refers to them as a directory. Okay, so in the case of which kind of gets funny. Linux is funny. The way it uses directories, you need to abandon your thinking when it comes to Linux as far as how data gets stored. It's kind of bizarre. Everything is stored into a directory, right? Once you install Linux, even system files and everything else, it's all at that very root directory. Even if it's on a drive, the drive gets mounted into a directory. It's really bizarre, and it's kind of hard to wrap your head around, kind of hard to explain, really. The best way to understand it is to see it, play with it, and work with it, and start to get your head around it. Somebody who really has a better understanding of Linux would probably have an easier time explaining this. I know how to work on it. I know how to fix it if it breaks. I know how to mount drives and do all the stuff that you need to do. But to explain it is pretty difficult. If anybody is like, oh, I really want to understand that, can you talk to me about that? I can probably show you, sit down and show you, and that would be the best way to really explain it. But essentially what you have is the dev directory is where all of your mount points go. So if you mount an optical drive, or if you have a USB drive in there, or any kind of hard drives, anything like that, anything that gets mounted, anything that has a volume would be put into this /dev directory. Okay, and so you have to think slash as your root, right? They always start with a slash, and then they throw in this case they throw in dev, and there's various directories for different purposes, like etc is for driver. Anyway, it gets bizarre. The Linux file system is kind of crazy, but especially when you have a Windows mindset, which I do totally. So it's definitely manageable. You can figure it out. But the best way for me to really explain that is to show you. So if anybody's really curious, I'd be happy to sit down and show you. Just let me know in class. Okay, so now we're going to look at some file systems and sort of the evolution of file systems for Windows. So it started with file allocation table, FAT. FAT16 was the original variety, and it's been around since the mid-1980s. Supported by most operating systems as far as accessibility. The big problem with FAT16 was that it had 16-bit addressing, meaning it was limited to the amount of data that could be allocated in a volume. So you couldn't go beyond 2 gigabytes in partition size. So by today's standards, 2 gigabytes seems a little bit weak. But that's where FAT32 came in. Was released by I don't know. It's not proprietary to Microsoft, though I think it was in part developed by them. Again, works with most operating systems. They can all access FAT32 and utilize it, and even mount a FAT32 volume. So, and it has a benefit of allowing partitions up to 2 terabytes, at least in, okay, right, okay, that's right, okay, so I'm sorry, I'm reading the slide here, but it has a maximum partition size of 2 terabytes, though the big problem with FAT32 is that once you hit anything beyond 32 gigabytes, you discover that the operation of that file system becomes incredibly slow, both writing data and reading data from that particular file system. Windows 2000 and Windows XP, if you decide to use FAT32 in Windows XP, would limit your partition size to 32 gigs so that you don't lose the speed. Now that being said, FAT32 was only around for a little while before Microsoft developed and I should point out, the FAT file system included no permissions, meaning if you have a user over here and a user over here on the same device, you can't limit their access to files, right? So if you're running a server and you want to do file sharing, for instance, you cannot use authorization to limit people's access to files because of the fact that permissions don't exist in FAT32. And I believe, okay, again, this is a CNT 110 lab, so some of you in CNT 110, you remember I can't remember how far back this was, but a few chapters ago, we did a lab where we create a FAT32 partition, and it adds a security tab when you change the partition table to partition table, FAT32 volume, and you change the volume table to NTFS. You change the file system to NTFS, right? When you do that, you notice that it adds a security tab to your files. And the reason why is because NTFS introduced a number of things. One of the main things it introduced was file permissions, that security tab where you could set permissions for users and groups on a file or folder. Okay. It also introduced disk quotas. This means you could limit the amount of data that a user's files can occupy on your disk. So, for instance, if you say, I only want my guest account to have access to 2 gigabytes worth of documents on the drive, they can't go over 2 gigabytes. Once they hit 2 gigabytes, they run out. It will not let them save anything else until they delete something. So disk quotas can be very beneficial if you have smaller drives. It's especially beneficial when you're sharing that resource, like on a server, right? If you have a file sharing server and you have a bunch of users that are sharing that, you might want to limit them. So disk quotas become very beneficial in that case. You also get volume mount points, meaning you don't need a drive letter to access the drive. You do need it for accessing the data on the drive, but you can look at the drive, you can tweak settings, you can play around without a drive letter allocated to it. You also get shadow copies, which are very beneficial for restoring old files. File compression, also very beneficial. This is like a zip file or .rar files are an example of a compressed file. Basically, taking your file, finding areas where you can run an algorithm that compresses it down. And also encrypting file system, meaning which encrypting file system, EFS, gives you the ability to actually encrypt data on a drive to where you have to have authentication to actually even read the data, regardless of permissions. Okay. All right. So here you see a screenshot of the quota tab, shadow copies tab, advanced attributes tab. This is where you can allow for compression and encryption. Okay. Excuse me. NTF permissions. NTF permissions have basically 2 modes, network and interactive, remote and local, in other words. Basically, if you share a file, there are permissions for the share. And if you have, and that file would also have local permissions. So, that being said, it's going to defer to the most restrictive permissions. That's the rules with NTFS. It says, okay, my sharing permissions are full control, full access, everybody has full rights, but the local permission says that this user has no access. That means that the user attempting to access it remotely, regardless of what the share permissions say, is going to defer to that local permission. If the local permission says everybody locally has full access, full rights, full privileges, but the share is limiting to just this user, just this particular type of access, then it will defer, if you're accessing it remotely, to that more restrictive permission. So you got to remember that when you're dealing with NTFS permissions, you need to remember that the permissions defer to the most restrictive permissions. So, and share permissions are only applied in the event that you're accessing it as a share or remotely. So those network permissions. And again, NTFS permissions always apply whether you're accessing it remotely or locally. So that's irrelevant as to what the share permissions are. So if the share permissions say full control and your local permissions say no control, again, it's deferring to the most restrictive permissions in the event that you're accessing it remotely. It's deferring to the local permissions and ignores the remote permissions if you're accessing it locally. So keep that in mind. This is something that when you deal with Windows Server and you start playing around in Windows Server 2016 or whatever the version that you use in classes, you're going to start to get a good understanding of this, because you have to actually do a bunch of labs where you change these settings. So I highly encourage anybody who wants to have a more thorough understanding in general of a lot of this topic or a lot of this discussion, take at least CNT 120 and CNT 121. And if you really want a thorough Windows Server understanding, 122 and 123 would be good. But that being said, CNT 120 will introduce you, and you'll play around with a lot of this stuff. And so I know a lot of people that are watching this are in CNT 120 and will be taking that and playing around. So permissions, essentially, they are the gatekeeper for file restrictions. Okay. So a good rule of thumb when you're assigning permissions, and this goes back to what is known as commonly as the principle of least privilege. It says that when you're trying to determine, okay, this group of users or this individual user, what permissions they need to have access, but what permissions do they need at the max? What is the maximum amount of the, permissions that they need? That's all I'm going to give them. So you figure out, okay, they need to have read access, they need to have execute access, but they don't need full control. So I'm not going to allow them full control, because I only want to give them the specific permissions. And there's a lot of permissions that you have to figure out and go through. And you can read up on what each one does. But really what it comes down to is, how is this user using the data within this folder? And then you restrict them to only access the data within that folder or within that share in a way that's going to give them the least amount of access. And the point of this is security, right? That's the whole point of permissions in the first place. Now, that being said, this is best practice. Personally, I'm just as guilty as the next guy of, whatever, they're not even going to know they have full control. Just give them full control. It doesn't matter, because it's not really a particularly secure folder. I've found that that can be quite a regrettable decision. When you give people more access than is necessary, you find out that if they get a virus or something on their computer, particularly, or some kind of ransomware on their, malware on their computer, particularly like ransomware, you can end up regretting the fact that you gave them so much control to the server or to that share's permissions, because it'll end up encrypting the data on that or causing problems or gaining access in some way or another. So restricting those permissions is a good thing. Figuring it out and taking the time to sit down and go, okay, what do I need to do here? This person only needs access for this purpose. And if you find out that you didn't quite set the permissions high enough, or you didn't quite give them all the access that they needed, you can always readjust and add more than you had previously. So it's a lot harder to take away once you've given than it is to give from a limited perspective. That's what I've found anyway. So early on, though, in my career, when I was a little bit more lazy doing things and setting up servers for the first time and trying to figure out, okay, who needs what, I said, just give them full control. Who cares? They're not even going to realize they have those permissions. Actually, it can bite you. So the principle of least privilege is definitely something to consider when you're assigning permissions. And you also need to remember permission inheritance. By default in Windows, any subdirectory, so if you have a share and then there's, down through the layers, there's subdirectories. If you have those directories that go down, through various layers of folders all the way down, you're going to inherit the parent folder permissions. So if you put a directory in, set the permissions on that directory, and then you create subdirectories down through that, by default, there is going to be inheritance. So you might need to change permissions, or disable inheritance on a particular folder or file based on certain criteria. So again, this is all kind of the stuff of like, figure it out, sit down, take the time. It's a good idea to document and take the time to really think about these things before you start implementing. If I could give one tip in my experiences, think it through before you start making decisions and before you start making changes. So, and if you can, test it on a dummy network or a dummy server or something that doesn't matter. You you can set up all your settings and make sure it all works. And then once you feel confident about it and once you feel good about the way you have it, then you move down and do it on your implementation network. Okay, so here are the NTFS standard permissions. There are more than these permissions if you go into advanced. I'm not going to talk about anymore. In fact, I'm not even really going to talk about these. I think that these are pretty self-explanatory. Even though they can be kind of tough to really figure out. Once you know what they are, I'll go ahead and defer to the book for people to look into these. But read and execute, list folder contents, write, modify, and full control. Modify and full control really have no difference other than the fact that if you give somebody full control, they can also change permissions for other people. So whether or not somebody knows how, good question. But modify and full control, the only difference, modify allows a user to do whatever they want within that folder, within that directory, except change the permission. Change the permissions for users or change the permissions for subfolders and stuff like that. So that being said, full control and modify, if you're just thinking, yeah, I want them to be able to do whatever they want, delete things, throw things out, whatever, modify is the way to go. Giving somebody full control is unwise unless they're an administrator who has, I guess some kind of security credential or verification that they are not going to do things that cause problems. So, okay. Linux, different distros support different file systems, though the two main file systems that are used in the most common distros like Ubuntu and Fedora and Debian and a lot of the main distros that you see, Kali or Mint, pretty much all use ext3 and ext4. In fact, I believe ext4 is on the rise now. RiserFS and XFS are more common with like the hack versions, like Hackintosh uses XFS and stuff like that, just to mimic Mac OS a little bit more. With Linux, there's only 3 permissions. It's a little bit more simple when it comes to the permissions. And combining permissions basically does the same thing as assigning a specific permission. So if you start combining permissions like read and write, basically they can delete and they can do all kinds of other things. So basically that would be, or read and execute, or write and execute. You can do all kinds of stuff with that. So that being said, the way permissions are assigned is in one of 3 types. You have permissions for a specific user, permissions for a group, and permissions for all other users. So this gets a little muddy as to how you assign the permissions. When you're trying to set up a user to have specific permissions to a folder, you would specify that you're assigning those permissions to that user. Same thing for a group. You would specify that you're assigning permissions for that group, and then you go in and change the permissions. So really what it looks like, here's a screenshot of, I believe this is a Fedora manager. Most often this is done in command line, but there is a GUI in some different distros, but this is from Fedora. But you see it's owner, this is the user, the owner is you, so you're changing your own permissions. What is the access you have? Currently read and write. The group, live user, this is the group that they're setting permissions for, has read and write, and others read only. So anybody else would only be able to read. They would not be. So if you don't fit into the user category, you don't fit into the group category, you would fit into the all others category. Okay. This basically mimics, in some ways, it mimics the share permissions in Windows, because there's basically 3 categories to which you can assign permissions: user, group, or everyone, right? And so very similar to that. In fact, kind of similar to the Windows permissions in that way as well. Tough to start drawing too many parallels here, so I'm not gonna do that. I'll let you figure that out. Okay, so that's where I'm going to pause for now because we're at 30 minutes just about, and I will upload this one very soon.